Okay, let's see. All right. Hello, everyone. We are doing a meeting about error handling. And there's a lot of complicated stuff on the screen, which I don't understand. So maybe somebody can explain what it is.
Right. Well, so, there are a couple of things we're probably aiming to talk about today. The first one is that we've reached a stage in this project where we've done a lot of design work. We have a big design document, and that's been going on over the last few months. But what we have now is an actual prototype implementation of some of those ideas. And we're also probably going to talk a bit about how we want to integrate, this work. What we're imagining will be kind of the new way of error handling with our existing ways of doing error handling.
Wait. This is language level error handling. This is not the UI of error handling. Is that correct?
Correct. This is functions and operations and semantics.
Okay. And just to be clear, my way of thinking about this continues to be, you write a piece of code and you mostly think about the primary code path that isn't the error path. And then you say, oh, but I need to bulletproof this code. What can I add to bulletproof this code? Is that the workflow that you're pursuing, or is that not the workflow you're pursuing?
So the general point of what we're at is where somebody who is intentionally, like, it's code that is doing some lower level operation is going to be issuing its own errors about what happened. So we have functions that, create errors and functions that handle errors, or the users can use to create errors and to handle errors. So it's more.
Is it solving the problem that I'm talking about, or is it solving a different problem?
No, I think it is partly solving that problem, because the whole point is that, right.
I don't think it's immediately. Sorry, but I don't think it's immediately. Go ahead.
Well, one of the main things that we're going to be talking about is about the sort of hierarchy of errors and so on, which is directly relevant to that, because I think that a lot of the way that you sort of bulletproof things is, well, first when you write something, it's sort of, it depends on how, you need a way of specifying what kinds of errors you care about and so on, and what places in the hierarchy you actually want to handle versus ignore. And that's one of the things it does.
Okay. But is it something that you expect that you have to put into the code right when you first write the code, or is it something that can be realistically put in as an add-on?
I think parts can be added on. I think that there's two different parts.
Wait, your audio keeps on mushing out. Just FYI.
Okay, I can check my mic, but no, I was just saying though. I think there's sort of two parts. There's sort of the consumer side and there's the producer side, right? There's the question of, I wrote this big long function and I'm only thinking about the primary code path, versus I'm using this function and I'm not thinking about, well, right. Basically there's the question of what, if there's a function from some package, what types of errors from that function do I care about and do I want to catch, versus the matter of, I wrote some big long piece of code and I need to sort of instrument it to add these different error cases, if that makes sense.
Yep. All right, so let's dive in. Let's look at some design here.
I agree with everything Christopher said, but I do want to say that the context for this discussion, this is kind of born out of, a desire to unify kind of the different conventions that have sprung up in Wolfram internal projects for doing error handling that kind of rhyme with each other, but we don't have a standard set of tools to do. So it comes from that kind of large scale software engineering background.
Okay, more so than an individual in a notebook piece of programming where you're just trying to handle more errors. So, do we imagine that the thing you have, let's look at function repository stuff, which is fairly small scale code mostly. Do we imagine that somebody could go in and say, oh, I'm going to take these function repository functions and I'm going to add some error handling with these kinds of tools to function repository entries? Is that realistic, or is that not what this is going for?
For the larger functions, I know Physics Project has a lot of functions that are made up of sub-functions. That probably could be reasonable. For really tiny kind of utility functions that are a composition of, a few other functions, it probably wouldn't make sense to use this.
All right, fine. Let's dive in.
Yeah. So, I mean, I think what I'm going to walk through first, and you can interrupt, with questions and everything as we go along. But this is kind of showing concretely what we've had before in a design notebook, but not implemented, and just showing how it actually works. And I should stress, this is the product of a couple of working meetings to flesh out this implementation. It's by no means finished or polished, and even names are a bit in flux. So,
roughly, how many functions are there how many different functions are there?
Oh, probably half a dozen right now. I mean, 6, something like that.
Okay.
I mean,
right, just getting a scope. Yep. Okay.
No,
go ahead.
That's fine. Yeah. So the first function, again, like I said, in a larger project, you want to develop a hierarchy of errors. The first thing you have to do is kind of declare that there is an error of a particular type. And errors, when we say errors, we mean specifically failure objects that have a tag of a specific type. So right now, I mean, in the language, we have failure objects.
And why isn't it called failure type? If it's about failure objects, create failure type.
Perhaps it should be. Yeah.
Okay.
But failure, right now we have conventions that failures take string tags. What we're proposing is that they take symbols as tags as well, but additionally that they can take lists of symbols. To
really want
kind of
muddy up the symbol table with this? Well, okay, so, that's a detailed thing. Okay.
I think absolutely yes. I mean, I think it's like there's a lot of value in being able to have, for example, a documented symbol where it's like this represents this kind of error, and here's its position in the hierarchy.
I see. I'm surprised that a pure symbol, as opposed to a head of a thing where there's an error type that has a foo with a bunch of innards in it.
Right. I mean, you could imagine instead of having a unified failure object, we have a different symbol for every one of these different cases, and you have some way of testing. Is this I don't know, not a failure object, but is this a failure thing, right? Where it might have any head, but I think that's much weirder and more complicated.
Yeah, but we don't really need to have symbols there. I mean, we have a lot of precedents for documenting strings like import types.
No, but okay, never mind.
So
documentation is not the main point. There's some tag there.
Yeah. The primary place that tag, the reason we want that to be a symbol is the first argument, there others have come up, is in packages, a symbol is automatically unique. You don't have to worry about namespacing it because its context is unique to your package.
I see. That would also be true if foo was a head there rather than just a naked symbol.
True. Yeah. I mean,
I think it's going to need more stuff packed in it.
Well, I think right. I think you should be a bit more patient because there's a reason why they want a list of symbols.
Okay, terrific.
Yeah.
Okay.
Yeah. So basic. I mean, this is stateful thing. You register an error type and ignore these info outputs. Here I'm registering an error type that doesn't have any other associated, like kind of the hierarchy of error types. It doesn't have anything associated with it, so there's an empty list here. But if it did, you would list them here. There's this expand tag function. This is not a function users are going to call. This is part of the implementation. But what it does is it does essentially kind of rule replacement on whatever tag you've is passed as an argument to expand it out into the full set of tags that are declared by that by that tag. So if foo is declared with maybe I could just show this.
I haven't understood these subtags, but I don't think I need to yet. Why don't you keep going, then we'll come back to
all right, sure. So now that we've registered this error type, we can pass it to raise. Raise is it's basically just throw with a custom error tag with argument validation that what it's throwing is a failure. So throw is kind of like generic control flow. Raise is, error specific exception control flow. So that's how you kind of throw one of these failures. Handle is a function that is what you use to catch these.
Hold on, but raise actually disrupts the control flow. It's like throw, it disrupts control flow at that point.
It disrupts control flow, and it does so unconditionally. There's no such thing as kind of like a quieted failure. If a raise appears in code, that means it's going to do control flow.
Okay.
It'll branch. So handle is how you catch these things, and by default, in its one argument form, it just handles everything that's been thrown. But we're not, this is kind of the quick and dirty way. We're imagining that people ought to be specifying rules to handle the errors they specifically know and care about. So I'm just going to register another error type. This is handle raising of something, but handling only the bar error type. So we can see that it lets through this foo error because, well, it didn't.
Why do you have to put that second argument to raise of the null association up in?
You don't. It's
okay,
just a prototype.
So this would otherwise just say handle of raise of foo, comma bar, and then it will the raise the foo will escape that handle because it was only handling bars.
Right.
Okay.
Right. But by the way, that association is there because you can put data there.
No, I realize that, but I'm just saying that the default case of the minimal raise doesn't, because the argument order here is a little bit funky, right? Because well, I see. The point is that raise effectively has no payload, because unlike throw, which has a payload that it throws to catch, raise has no payload.
Well, the payload is constructed, so it constructs a failure object that is then thrown.
Right, but so I understand that. But throw, you can throw a ball, and there's an actual ball to be caught. Whereas raise is just like, oh, I'm raising a flag. Nobody gets the flag, so to speak. It's just raise.
Well, no, raise does throw a ball. It's just the ball is always a failure object, and it can if it just knows the tag, it can construct a simple failure.
No, I get it. So, but the main point is that throw needs a payload as its first argument, which is the thing you're throwing, whereas raise does not, because it only
does need a tag.
Well, hold on,
which is part of the payload.
I think let's tease this out, because I think maybe Stephen, what you're trying to say, and tell me if I'm wrong, is raise as an implementation detail constructs a failure object that it throws. But you can imagine a different implementation where no failure is constructed if it's not actually handled anywhere and the object isn't needed.
I'm saying
I would say raise is it's more like raising a semaphore than raising a flag, right? Because there might be nothing written on it, but there could be some very complicated sequence of stuff with useful information in it.
I get it, but the thing is, raise is a one-trick throw, so to speak, in the sense that you can throw the actual data that you wanted to get, whereas raise you can only throw there is an error condition here.
Yes.
Okay. Fine.
You can include. You have to include the metadata at a sub level. It's not. Yeah.
Right. So if you're communicating, I mean, I'm just trying to understand how we explain things to people. So throw is you are disrupting the control flow, but you are delivering some actual data that you're throwing to the catch. Whereas here, the thing that bothers me. Okay, I got to say, the term raise, and now I admit that I'm getting into naming. The thing raise just is like, oh yeah, we'll fly this flag. That's nice, and we'll keep going, right? It doesn't make it as clear. I mean, throw is much more of an action. I don't know. It's somehow maybe it's just because I've used it for so long. But
in other languages, I think people use the term raise an exception, which is a kind of a catastrophic situation.
Yeah, I know.
And the problem with throw is that we have these 1 and 2 argument forms, and it's just a very awkward thing to use, I think. Keeping the thing that is passed up to be structured for this kind of error handling, I think is
no. It's the right thing. It's the right thing. I'm just saying, in terms of distinguishing the throw functionality from the raise functionality, I understand the distinction. I'm a little bit unconvinced about the name raise. But let's keep going.
We can revisit it. Yeah.
Okay. All right.
One thing about the handler rules, like the second argument, I see that you're doing a replacement and you return a function.
So we can talk about that. We spelled out a lot of different possible designs for what this could look like. What, it's a rule delayed. Is this, a thing that is applied? Is it a function object? What is it? This is what we settled on, and we can discuss the trade-offs if you want to get into that. But it was not chosen arbitrarily.
Well, it's just that I don't think I've never seen in the language something where you do a replacement and you return a function.
Oh yeah,
we do. Where?
I mean, I don't know, if you say nearest functions in a options to nearest or something. Why is that? Yeah, I mean that's a very traditional. Yeah, it's just an option, nearest function arrow, and then there's a function.
Well, except that this is a replacement; it's not an option.
So before we get into that, let me mention this is not strictly a pattern. Like you can't put an arbitrary pattern in here. This has to be a list of tags or a single tag.
Okay, that's weird. That's weird because then that's sort of hijacking the colon greater than, thing. Well, okay. Again, let's get the bigger picture before we go into. Okay, so let me just understand what this is doing. So this, as a side effect, is executing that function on what? What is the hash?
So on the hash is the failure. Yeah, that's what's printed.
Okay, but this thing is saying you're handling
any error that has the tag foo, and it's kind of it's like a contains any sort of thing. So if this was like foo or bar, this would handle any exception that has the tag foo or the tag bar. I mean,
why isn't that foo vertical bar? Why isn't
actually
that?
I mean, you're saying that out loud. Yeah, I'm not sure that's right. I mean, this is a finer point that has not been worked through.
Okay, all right, okay. I mean, that it seems to me using the pattern language makes sense here. But I've got a different question. In the ancient event handler function, how does it deal with the different? Can we look at the documentation for event handler? Because it has a way. Yeah. So
it's very much like what we were just talking about,
except that it's using expression evaluation rather than function application. But it's a very similar idea.
Yeah. But the expression evaluation only makes sense because of crazy dynamic stuff.
Yeah. Okay, so let's keep going.
Right. So that's handling. So this is where we get into advice. So I want to there's kind of, I've been thinking this in my head of like the, if there's like an iceberg, there's like the above the water line and the below the water line, and they have different rules. So errors are things that unconditionally trigger control flow. If you have a raise, that always causes control flow, and the reader of the code can rely on that. Advice is something more analogous to messages, where if you have it's code outside of the thing issuing the advice that decides whether to do control flow. It's like check mechanisms.
I'm sorry, excuse me. I'm as you're saying this, the word exception will be a better word than raise, because raise, it just sounds so passive. It's like nothing's going to happen here.
Yeah,
but
exception seems to be inert.
Yeah, exception sounds like just an object, and raise is the term in many languages used.
I know,
yes,
but they say
raise is an exception.
Yes, I know raise is an exception, but do they use the term raise, or do they use the keyword raise?
In Python, yes, I think. No, wait, Python is raise.
Yes.
Well, okay.
Yeah.
I don't know. I don't like it. It seems too.
It's throwing node in JavaScript, I guess. What's Rust doing?
Rust doesn't have exceptions
like that. Yeah.
Anyway, the point should be, I mean, you can call it except, but
no,
already, but it's supposed to be a verb.
We already have an except in pattern matching.
Yeah, but again,
stop confusing it with throw. It's we got to be able to document. Throw throws an expression that you want to, whose value you want to use. Raise, generates sort of disrupts control.
I think this is the wrong distinction.
All right. Okay.
I mean, because the raise, the thing currently called raise, throws a failure object effectively that you want to then
I know, but
then you might decide what to do next, so you're consuming it, right?
But you're deciding what to do next, as opposed to that is my prize. I went down into the salt mines and I found this amazing ruby or something, and I throw it back up, and that's my result.
Well, no, it might be the prize, because if you're writing some package and you have some function, and it failed, the prize result is that failure object.
Okay, but
in fact, that's a large fraction of the uses of throw right now.
Maybe, but not the only uses. I use throw when I'm doing a search, and I finally find something and I throw the result.
Sure. But I'm just saying, I think the real distinction is the real reason why we shouldn't use the word throw anywhere near here is because I think the ways of managing them is totally different. Like, for example, you don't use catch to catch these things.
By the way, the term fail is interesting, which you just wrote down. Anyway, let's keep going. Let's not get hung up on this name. Let's talk about advice.
Okay. Yeah. So advice, and this is another thing where the name is placeholder, but advice is analogous to messages. They can trigger control flow, but they don't have to, and probably typically won't trigger control flow. So similarly to a lot of the things in the structure of advice is similar to what we're imagining is the structure of failures. So they have tags as well. Though I guess here we don't actually have a registration mechanism, but you would register some kind of listener. This is just a function, and our function
advice is a noun, like failure.
Advice is a noun.
Advice.
So you have an advice object or something. This name is way more in flux than failure.
Right. We talked about this recently because this name is very unclear, if nothing else, because the thing for throwing an advice, the function for throwing an advice, one of the things we considered was advise, but that's impossible to have advice and advise.
Okay. Well, all right. But anyway, so this is, gosh. It's an interesting concept. Okay, so this is a symbolic advice construct. Okay.
Yeah, but and the analogy for this though is these are kind of like glorified messages.
Yeah,
and the main advantage. The main advantages are both that the ways of sort of catching and managing them will hopefully be simpler than messages, or better than messages, but also that you can include real data in them, because right now with messages, it's just a string that gets printed. You can't include useful copyable
stuff. A very
stuff.
bureaucratic name would be advisory.
But can I suggest it's like this system is actually very interesting, but it's like a signal, right? There are other, you are basically emitting a signal, and then another guy is registering and handling for the signal, and you can do it something more than just messages with it. It's you're sending an event, and then another guy is listening to that event, right?
Yeah,
it's more general than messages. It could be used potentially for a bunch of other things as well. So basically you have to think about it as certain propagation of some information occurring early in the stack, in the execution stack, upward to the upper callers of that function.
In general, this is a very interesting concept that I think we should try to. We could propagate it a little bit. Imagine like, you want to connect something that is doing something when you do cloud deploy, or when you do import or export or other stuff like that. So in general, function could have their own handlers and say, before I'm running this, I'm going to send this signal out so that you can register and do stuff.
Well, this is a better version of the thing that I've been pushing for years, which is messages that are off by default. You're saying that an import could send out some advisories that say, oh, by the way, this file has this or that properties. You may not care about that. You may not want to actually pay attention to that piece of advice, or you may want to. But
in general, you could connect something that is doing something else every time we run export, right? So you can intercept every export call and do something else, like whatever.
Well, we haven't thought about it in a great depth, but one thing we were thinking about was to actually restrict the non-locality of which functions in which order can intercept things. We wanted this to be as unobtrusive in terms of diverting the standard control flow as possible. In contrast to errors.
Yeah. Okay. One of the things we want to keep in mind is that what we're talking about here is the low-level substrate for building robust programs. So if there's too much complexity and unpredictability in that substrate, that kind of is a permanent shaky foundation. So we want to be clear, we don't want to have something that is as general as we could possibly imagine it to be, because that makes it hard.
But I mean, basically what's happening is you're putting bottles out in the ocean with these advice objects, and the sender doesn't necessarily, you want it to be the case that the sender has no idea where it's going to land.
Yeah.
Whereas in the case of rays, the sender is just giving up and saying, I'm out of, get out of here.
Yeah, and Stephen, in this analogy, the sender in the case of rays, they'll just shoot something straight to the sky. Well, here they just put this bottle, and whoever picks that up does with that whatever they want.
Yes. Right. Okay. I mean, I think they're both interesting mechanisms. So, okay, keep going. Okay.
Right.
So
well, we're near the end. But just these are some examples of, we're trying to come up with concrete motivation for these. So this is an example showing you might have a service that, handling login events, and you may not care about that, but you may want to kind of, as they happen, do something like log them to an output and include actual useful information in them. So this is just an example of that. Another thing is, we've talked for a long time, we have these messages for array unpacking, but they are not actually, as I understand it, some people have complained that they're not super useful for tracking down where the unpacking happened. So we could imagine a more robust unpacking event type thing that actually says what is the content of the array that was unpacked, and maybe an optional operation field that could say, well, hey, this array was unpacked while doing an append to operation.
Yeah, the basic point is that a message, I mean, our convention for messages, let's review messages. Invented, 36 years ago or something now. Okay. A message has slots that are really only intended for human consumption. That is, if you look at the text of a message, if you bring up a message, I mean, let's say general : arg count, argct. Okay. That's a typical message. All right. Now, this message effectively, I mean, the alternative thing to do here would be, would have been, or would still be, that, that thing can be applied as a string template, right? Right now, if you take that object, you say string template of that object.
Yeah.
So just get that string template. Okay, now apply that. Well, apply that string template to, I think, do you apply it to a list or is it varargs?
I think it's a list. So like,
if you apply like that, it's varargs.
Okay, all right. So say A, comma B there. Okay, all right, fine. So this is a positional, this is positional. Now, what you're suggesting is that your more general thing, your more general advice object routinely takes an association, whereas messages right now are expecting essentially, positional arguments. Am I making sense?
Mm-hmm.
Also, Stephen, message by itself is a side effect, while what we are doing here by itself does not produce any side effect per se.
No, I understand. Message actually, by default, I mean, okay, this is why I keep on emphasizing messages that are off by default. Okay? I mean, in the end, we will have to make a bridge between this mechanism that you're proposing and the messages mechanism, possibly subsuming the messages mechanism inside the advisory mechanism. Okay?
Yeah.
Now, why do you claim that this advice mechanism can help with unpacking? I mean, right, the problem with unpacking is that, right, it's done in the evaluator. It doesn't actually happen during any particular evaluation. So I don't see how this is helping with.
No, I understand. The point here is what is generated. The issue is the unpacking messages are off by default.
Yep.
And point one. And the question is then, how do you discover and make use of messages that are off by default? And the answer is right now, you just very ham-fistedly switch them on. Okay? And then they display. But even making use of, if you wanted to programmatically make use of them, that's not easy to do. Problem number one. Problem number two, the material that is provided to the messages, well, we could probably look up the packing message. What does it have? What is the data for the packing messages? Is it general unpack or something? What is it called?
Yeah, I don't. Itai, do you know? I've never actually used them.
I don't know the tag off the top of my head. Right, you do on of packing and then
sorry, on of
so if
packing.
You do
No, packing.
Dollar message groups.
Oh, packing. Okay. Oh, is there a group for it?
Oh yeah,
I can assume that there's a message group for it if you care
packing.
about general unpack.
Okay, that's
okay. So let's say just look at what general unpack has in it.
Why don't you just map over like a range with some uncompilable function or something like that?
Well, fine, but this is showing us the junior version of what will be the unpacking advisory. Right? The unpacking advisory would have an association with more stuff. This just has one positional argument. Right?
Right.
right.
Yeah.
Because presumably that's all the information that's available, right? I mean, you can see that there are like 5 different messages there.
Yeah.
Depending on exactly
Okay.
where.
That's an implementation feature of the fact that the
Right. Well, right. Well, but wait. Connor made the claim that people complain about the lack of information, and we could use this to provide more information.
Well, we can't.
My claim is there will be exactly the same amount of information.
Yes, right. Itai. This would be a place were we to put hooks in the code to deliver more information. In this case, we actually have a way to deliver more information, as opposed to messages where all we can do is produce some positional arguments.
No, there's exactly the same amount of information.
Okay, hold on. I think this is not the point, right? I mean, I included this as an example. Maybe it's a bad example, right? I mean, but
it's a bad example. The internal code produces some amount of telemetry. And you can package that telemetry in an advisory object or in a message, but it's still producing the same amount of telemetry. Correct, Itai?
Sure.
Okay. Now,
Stephen, one thing I wanted to add is that there are other things we might want to include, like a stack trace, which could be a useful thing for this new system.
That's fine. Can I make a point? The word telemetry, I kind of think is an interesting term, maybe too weird. But I just think that's an interesting term for those advisory things, because that's really what it is, isn't it? I mean, telemetry is not something where you don't expect the spacecraft to immediately, fire its thrusters as a result of sending out a piece of telemetry.
Although I would argue telemetry makes it sound more like logging.
Yeah, I agree.
Yeah, I think telemetry also has a slightly negative connotation, unfortunately.
Why?
In some circles. Well, I mean, I'm not saying everyone feels this way, but people it's the word when people complain about an app that has been sharing too much information about them. It's kind of
fine. All right. Anyway, just a conceptual thing. Okay. All right. So let's go back up then. So what is the relationship? Okay. So we've got, I'm still confused about something. Okay. So at the beginning, could you go scroll up to the top? So we've got these raises, which are raises according to a tag. You don't get to raise unless you can specify a tag. There is no generic raise, correct?
Unlike the moment,
a throw,
yeah.
Well, no, you shouldn't say at the moment, because you don't want that. You don't want it. I mean, that as soon as we have a generic raise, we've basically just re-implemented throw.
So I agree conceptually, but the problem is, and this may not be a problem, right? But I think it's worth recognizing that there's the slight UX challenge here of having to register an error type. It's fine, but it's a little onerous, especially if you're trying to quickly work through code where maybe you want to include error handling. You don't even know what all of your final error types are going to be. There's kind of like this happens to me. I'm working through a project. I want to add error handling to it, but all I really know about the error at the moment is like something went wrong, and I want to just raise something that has like a string message and some arguments.
Okay.
And that's
okay.
This
so
is
this
a problem
is the
that
flow. Let's talk about what this looks like to the programmer. Okay. So you did something, and maybe even when you're initially writing the code, there is this was an error case, but you have not yet defined a taxonomy of errors.
Yeah.
Therefore, you have not yet invented your tags.
Yeah.
Right.
I mean, we could have some top level tag that is always present, right? If we really wanted. Like.
Yeah, we have actually at the top of the hierarchy, internally, we have a general error that's going to be the parent tag of them all.
What's this with parent tags? I don't understand the subtag.
Yeah, so this, Steven, this has been a part that we haven't discussed yet. Basically, tags can be inherited. So this allows us to build the taxonomies or the hierarchies of errors, because certain errors can be more general and include sub-errors, or there are specific cases.
Okay, so hold on a second. Again, let's zoom out for a second, because we have to remember the thing I keep on emphasizing. This is essentially automatic programming, not in the same sense that people meant automatic programming in the 1950s, where they meant it was doing Fortran rather than machine code. But it's automatic programming, as in you're trying to effectively get functionality written without explicitly writing it, because you're trying to like bucket different, code paths, et cetera, et cetera, et cetera. So I want to ask this question. The notion of hierarchical errors, is that in fact a natural notion in all cases? Insofar as we're automating programming, I mean, this was one of the things, this was the object-oriented programming idea, in a sense, was this kind of hierarchy. Maybe, I don't know. I mean, is it the right idea?
I think
is that
yes.
What you want to do? Okay.
Oh, and I think the others share that view as well. Think about them as more as scoping, because can you imagine programming without scoping? I guess not.
Okay, so scoping is hierarchical. So
yes.
You're saying, and that has worked well to have, I mean, that was the thing where when first people were trying to, do code, invent lambdas and then do code with lambdas, people didn't know. I mean, there is wackiness in scoping. Like you've got an X on the outside, and is it the same X as the X on the inside, and so on. But okay, so your argument is scoping is tree-like and hierarchical. And
yeah, and this hierarchy here, in some sense, can be considered an analog of scoping in the world of errors, in some sense. And the scoping here means that basically you only want to catch certain classes of errors, but not others.
Yeah. Now I do
but
think. I mean,
is it a good idea to think it about in terms of inheritance rather than traits?
Oh, I think we could think about this as like message groups, right? Message groups give you a bunch of, right? You only turn on or off one thing that controls a bunch of specific cases, and here you could, define, right, arg count errors, right, and then.
I'm just not clear that containment is the right thing, because like there's an error. Okay, let's say numerical round-off errors of various kinds. Okay. There's one that's a round-off error. There's one that's a convergence error. There's one that's a something else error. Why aren't those intersecting groups of errors? Why do you think that there's a hierarchy to groups of errors?
Right. I mean, this is why I was saying that probably we should think about in terms of traits rather than inheritance, because let's say that you want to combine together two things that I'm not sure you should do it, but let's say for the sake of the argument that you want to do it, like a zero division error and a file not found error.
Mm-hmm.
If you do it in terms of inheritance, normally it's going to be a mess, right? Because they expect different things. So you need something clear that says, that a zero division error got this kind of payload, and the file not found got this other payload, and you can combine them together.
Yeah.
So maybe two quick.
Sorry, go ahead.
Well,
Okay.
I was just gonna say maybe two quick clarifications. I mean, one thing is that of course you could, you could catch or handle multiple errors at once. So you could handle, errors from division by zero and final not found at the same thing. The other thing is that, I mean, for the structure of the hierarchy, I think we talked about it being a DAG, not a tree. So some of the issues
it's really multiple inheritance. It's
multiple inheritance. Yeah.
And I think that we have to think mostly about inheritance as about a way to form groups of errors that we want to catch.
I'm confused because if you've clustered together two errors, but yet their association keys are different, how can you have a function that applies to both of them?
Well, this will bring us more towards the internals of what we do there, but we plan that there will be certain validators that the author of a given package or whoever creates certain types of errors, they would know what form of error they want to be produced. And so they will define validators that will basically tell whether this error is actually well formed or not.
No, but the point that I'm making is, the thing that's pretty confusing is right now, for a message, it is just positional. You feed it. I'm sure we could generate an error upon an error by feeding a message a collection of arguments that it wasn't expecting. Okay, so similarly here, the question is, it's got certain keys that it is going to generate.
Right. So I think the idea is that suppose you had some category of, like, I don't know, numerical error or something like that, which includes, convergence and who knows why, I don't know what it is, but suppose you have something like that. The idea is that you would specify sort of a validator for testing whether a numerical error that you gave is really a well-formed numerical error. And you'd expect that would be something like checking that it has certain keys in its association. And so then the idea is that when you declare that, when you declare that, oh, I have a particular thing, I have a convergence error, and this inherits from, or this is a child of the numerical error, then, that's something that you have to specify when you create that sub error type. And so you're sort of responsible for knowing that, well, okay, so then now this sub error type, like, it has to, in order for an error to pass, it has to pass the validator for the sub error and the super error.
Yeah. And again, the point there is, you asked about clashing. I think the point is that you are taking responsibility for having checked that these error fields are distinct if you're going to declare that they have an inheritance relationship. You can't, you have to have this explicit create error type to create one of these things that has multiple tags in the same failure object. You can't, there's no mechanism where that kind of handle happens automatically for errors that weren't declared to be compatible by someone.
All right, so hold on. Let's just understand the way you write this code. So you raise something with a tag. I don't understand why the tag and the association are separated, but anyway, okay.
This is,
to me,
the tag is a shorthand for, you could write this if you wanted to. But which this does work. Like, we're planning to implement that, but it's
people
are going to have a lot of these, so we want to make it as short as possible.
I think that's a separate level of issue, but okay, all right. So then, okay, so now you're going to handle this. And the first point about handle is it stops the sort of throwing of control flow. It's propagated out to the point where it hits the handle, and then the handle evaluates, much like in closed confirm. The handle then does whatever the handler says in its side effect argument it's supposed to do. And then what does the handle return? What does handle return?
I think it would probably return the result of these right-hand sides.
I mean, isn't it just a replace over the catch that you're doing?
Basically, yeah.
Wait. So
I mean, it's not really
unlike a throw, for example, where, let's say you're doing a search and you say, I found something. Here it is. You throw it. The result of the search is the thing you found. Okay, and then you keep going with the code. In this case, it's almost like this is just an element of a compound expression that has nothing going on other than producing a side effect, which is pretty weird. I don't understand how handle would get used in code.
No, Stephen, it's different here. Basically, the first handler that matches the tag is applied, and it's not necessarily a side effect. The right-hand side of this handler is what the result will be.
Yeah, okay, I understand. So what the heck is this like? I mean, there is a style of coding in which you just give a result and you say / dot blah blah blah. That's kind of what this is doing. This is like a switch, basically.
Yes. It's a switch that catches as well. Like it catches and switches.
And which also falls through for any exception that has the tag not matching by any of the handlers. They will just fall through.
But what do you mean by fall through? It means the failure is still flying.
Yes.
Exactly. Yeah. If you haven't written the handler for it, the failure goes through. And I want to stress, I mean, this may not be a direct analog for this in Wolfram language, but this is essentially equivalent to catch in many programming languages. Our catch is actually unusual in that it doesn't allow kind of specification of the kinds of things you want to catch. Like we use tags, but tags are kind of out of band mechanism. In many languages,
I understand.
Yeah.
How does this relate to enclose confirm?
Enclose confirm has to propagate things rather locally from one layer to another. If for exceptions, you can sort of pierce through a whole stack of intermediate function calls.
So instead of enclose, I mean, couldn't confirm keep flying until this is a thing where you're sending you're exceptioning, and it keeps flying until you finally get to a net that catches you. Correct?
Correct.
Yes.
Doesn't enclose have a mechanism to do that as well? But it's not its default case. Its default case is the lexical.
It's tags. You can use tags in enclose, much like you can in
Right, I understand, but the default is the lexical confirm enclose, which is the most useful case. Christopher, is that right?
Yes.
Yeah.
When you start using tags, it's already becoming another version of what we're proposing here.
Well, but we can't have 7 versions of it, so.
Right. I think probably right. I mean, I think
your audio is still broken, Christopher. There's some packet loss. Anyway, never mind. I'm just complaining. Go ahead.
Well, I was going to say, I think the main value in this newer stuff is first of all the categorization and hierarchy of errors, and then sort of better sort of automated creation and handling of failure objects. And then some more non-local propagation stuff. But yeah.
Right. But so
there's also maybe something to keep in mind, that these examples where the handler just prints something and so on are not what I would expect to be typical. Typically, say you have code that reads one file, and eventually that file is over, and there will be an error raised, end of file error. And then the handler would not print anything because it just returns the result. So it completely gobbles up the error, and the error, the end of file error isn't really an error. So you would normally see handlers to just return results and be silent about what happened for these kinds of messages that are not
right. So
errors.
It's like in a sense, the thing you just described well, let's see. The one version of that code would be that there's a symbolic representation of end of file, which we have, and that you have an if statement basically wrapped around the place where you read from the file that says if it's the end of file thing, then
raise that error. Yes.
Well, no, but what you're saying here is that the style of programming you're proposing is that it's kind of, you're just going merrily along, you're doing whatever you're doing, reading things from the file, and maybe building up some intermediate data structure. And then on end of file, yeah, that's the first thing. The first case, those are two alternate cases.
Yeah, I mean, the kind of thing we have that so far we have always, our error handling was through return values and if statements, right? And that is what your original comment was today in the meeting. I mean, it should be possible to write a piece of code where you don't even see that if statement, where you just pretend that it goes on forever, and outside there is the handler which then triggers on that exception that is raised.
Right. So that's the point. The point is, it's like messages that are off by default. You're merrily running your code, and if something weird happens, see, the thing I'm not understanding. Here's the thing I'm not understanding. Okay, and maybe this is your advisory concept as well. Yeah, maybe this is the right thing. Sometimes you want a thing that from the inside says, I'm giving up. I'm sending up my, escape pod or whatever. I'm done. I can't, I'm pressing the eject button. Okay.
Yes, but I mean, one
as opposed to the other case where you keep flying, but something from the outside says, excuse me, airplane, your engine is on fire or whatever. Right. One thing is you from inside the airplane pull the eject handle and you're ejecting. Right. And you can't go back. The other case is you are simply sort of advising the world that this is happening. And then the world from the outside is telling you, no, stop. Do this thing. Is that correct? Is that how I should?
Yes, it's correct, except that we would prefer to not use the advisor mechanism to abruptly change the control flow. We would prefer to use that as a kind of information propagation, so that the intermediate layers through which that propagates may decide that for some reason they want to stop or something.
Hold on, I didn't understand that. So hold on. Look, there are two cases. One is, okay. Actually, there's another case. Look, messages off by default are automatic pieces of advice being generated, right, which I don't think you're dealing with here. I mean, I'm saying there might be things in the code which I claim we should sprinkle all over the place, which are messages off by default, which you can choose to put up a net and catch them if you want to.
Yeah, but that's exactly what we are suggesting as well, was this event-based mechanism.
Which event mechanism?
Well, if we go back to how we think of advice and how it's going to work, currently we are basing that on a certain event propagation model, which is very similar to what you are describing.
No, but look. In the internal code, we have a small number of messages off by default, like the packing messages. Okay.
Oh, it's more than a small number of messages off by default.
Okay, fine. But I'm saying what I have thought for a long time is that we should have vastly more messages that are off by default. Now, we may want to present them as different things than messages, but although that is a pretty good mechanism that we have right now, that are all kinds of things about, sort of little, oh, that might not be the right thing. Oh, that's going to give a symbolic result where, in fact, that's probably meaningless, but it might not be meaningless, right? And so then the idea would be that you could have a block of code, and maybe this is essentially what you have, where you say from outside the block of code, you say, if any of the following weird things happened inside this code, I want to generate a failure. Am I making sense?
Yeah.
We would have this mechanism, but I think that we would still prefer to discourage this kind of uses.
Why?
Because whenever you're trying to decide about certain things which are happening inside code from the outside, this is very hard to make robust and predictable.
Yes, but look, no.
I mean, I
yes
think,
and no.
Yeah, I don't think.
Can I ask a question? Like there is one specific use case, for example, right? That you can use these advanced mechanisms that I'm thinking. So let's say that I'm trying to deliver pizza. And the function is very simple. There is one guy that is producing pizza and it ends up to a guy that is taking the pizza, right? Now, let's say that you can have an handler that is putting, I don't know, like pepperoni on pizza. And what's gonna happen? Like, so can you do that? Can you alter the payload of the function? And another question, can you have like another layer that is doing, I don't know, like QA, where you take the pizza and you inspect and you say this doesn't meet the standards, so you throw an exception. Can you do this kind of stuff?
Well, I mean, that's basically, as the message passes upward, can it be monkeyed with? Which is right. What confirm and close is a, you're going to monkey because it does not propagate. It actively requires you to sort of repeat it, so to speak. Is that a fair statement? Whereas here, you're saying this will float upwards by default and not be stopped until it hits a handler. And so Ricardo is raising the question, could you, as it floats upwards, could you start decorating it? Which I think is a different issue, but a perfectly good issue, that there's a thing which is not, the handler is a sink. It's going to stop it right there and do something with it. Ricardo is proposing that there be some decorator mechanism that can do things to it as it floats upwards. Oh, by the way, if you had this message, take a look at it and then propagate it upwards. I mean, you might do that by handling it and then recreating the message to propagate upwards.
Right, yeah, because this allows to do like all kinds of stuff. So, for example, in Django, Django, the web framework. So they send out messages every time you log in or log out that allows you to, for example, send an email to the guy that says, oh, someone logged in your name because there was this login event. And now, like, can you also like change user information? Can you do this kind of stuff as when the events propagate before it actually reach the end of the lifetime?
Right, but the point is, if you repeat it, if you actively repeat it, if you hit a handler, the handler is a sink, it absorbs the message, but the handler, as it's handling code, could regenerate the message. So the answer is yes, but it isn't like it floats by and you put a party hat on it. It's rather you stop and you remake the pizza, putting a party hat on it when you remake it.
Right. Although if we do any sort of, automatic data addition like the stack, right, that'll be wrong because it'll be the stack at the point of where the handler was rather than the stack of when the thing was originally issued.
Okay.
Or
so you're arguing
won't be exactly equivalent to.
Right. You're arguing for the need for a decorator function.
Possibly.
Okay. But
yeah, that's a good use case.
By the way, this is why we called this listener and not handler, because conceptually a handler is like a thing that it's handled it's over, it's done. Whereas a listener is a bit more passive, something that, it receives it, but it's not going to modify it or do anything with it necessarily.
Well, but does it keep on floating upwards? So
if you register multiple listeners, they all run. It's not like the first one gets to decide whether to continue.
Right, so it's only a handler that stops it.
Yeah.
But a handler, right now, the advice thing wasn't, these are not interoperable. I mean, you're either generating arrays or you're generating an advisory. Why aren't they interoperable?
We imagine that there could be somewhere I had an example. Let me just see real quick. That handler would have a syntax to, well, let me just write it because it'll be easier. That you could have something like handle of expr, and again, pseudo syntax, but something that just says this tag is an advice tag, not an error tag. Or maybe, I mean, perhaps you would even just say just foo, but I'm not so sure about that.
So listen. The way to think about this, I think, is this. There are absorbing handlers and there are non-absorbing handlers. Right? A listener is a non-absorbing handler. And a handler, okay, the point is this. A listener, okay, if you write out, yeah, right.
But why isn't it just a chain of composition? I mean, why is it just a pipeline, like, you know, a composition of function? If you register identity, is not doing anything.
I'll tell you why. Yeah. It's rather simple. Okay, so let's look at the function, you know, handle of expr. Okay, and then it specifies how it handles things. Right? Handle returns some piece of its second argument as the result, whereas listener returns its first argument as the result. Right? In absorbing, you're returning part of the handling operation, so to speak. Right? Listener is a non-absorbing function. And so the difference is, does it return the first argument or does it return, you know, in other words, it runs the second argument. Both of them run the second argument. The question is, does it return the first argument, which can then keep floating upwards, or does it return the result of the second argument? Do you see what I'm saying?
Just to be clear, so are you suggesting, I mean, we might have hypothetically something like, and register, I mean, this really shouldn't be stateful. It should be something like with listener or something.
Yeah, it's not the right thing, right? But so what you want is something that just says, listen, yeah, that's fine. I mean, we've already got.
So basically,
Steven, look at this. Okay, just okay. What you've got is listen, and then the second argument there is, let's say, you know, action or event arrow action. Just write event arrow action or event arrow action fun or something. Okay, all right. So now write handle of expr event arrow action fun. Okay, so the point I'm making is the only difference between these functions is the return value. If you write arrow, you know, after the listen thing, just write an arrow to indicate its return value. The return value is just expr here. It's always just expr, right? Whereas in the handle, the return value is action func of blah, blah, blah.
Yes, and this necessarily means that in this formulation, listeners should always be side effects of source.
That's correct. A listener is a pure side effect here. It is not an absorber.
Exactly.
But does a listener necessarily have to wrap itself around what's happening, or could it be in a coroutine, in a separate thread?
How?
That's a different issue. I mean, a coroutine version of that is a separate issue. But I agree that that's an interesting case. But right now, in our sort of functional structure design, that would be, to me, the difference between those two cases. It's a perfectly reasonable difference. Okay, so now the question is the management of the events. Given that we understand roughly what handle and listen, which aren't the right names, should be doing, you know, now you've got the question of event type management. And you've got this question of the naive thing to do. What are you doing? Okay. Okay, the naive thing to do. I don't understand why you have to register the events. I don't understand that. Why do you need to register the events? Why isn't it just that Okay, okay, and the thing that generates something for both of these. Okay, so then you've got the ejector and the whatever it is. You've got that's the on the outside. That's the absorbent and non-absorbing. Then the two cases on the inside are, eject and advise, basically. Does that make sense?
I mean, by inside, you mean like in the code? That's
in the
Expert.
code. In the code, inside Expert, you've got two cases, which we can call, this is not types of handlers. This is types of.
Could be emit.
Yeah, we've already got a function called emit, but it doesn't matter. I mean,
Wait, do we?
Yes.
Oh, emit sound. Yeah.
Inner level. Okay, the inner level is both. Don't worry about the names. Let's call it eject for now.
Propagate.
No, I mean, don't worry about the names. Okay, we understand eject, raise, whatever. It's ejecting from that piece of code. Okay, so case number 1 is eject. Case number 2 is advise. Okay, so both of them they take basically, I don't like this. They take a tag and some payload material, right? Both of them take a tag and payload material. Right? And advise has a return value. This is a mistake. It's the same mistake as print versus echo. Okay? Advise wants to be some kind of sub-value thing, I think, because advise, as you have it right there, is something that, what's its return value? Because it's still in the code. You see what I'm saying?
Yeah. I mean, I guess we have been imagining it implicitly as null.
But I don't think that's right. That's the print versus echo mistake. That echo is the vastly more useful function than print. You see what I'm saying? Because echo, you can just insert in code, whereas, print, you have to put semicolons and things.
Yeah.
So I claim this thing, I don't know its name, but I claim it should have a sub-value thing. That it should, basically the form of the code should be advisory of tag, payload of expa. Just like echo. And you can even put an echo around it if you wanted to. Am I making sense?
I mean, I understand what you want me to transcribe. I guess I don't understand the behavior yet.
Okay, here's the point. The point is, you want that advisory thing to return expa, right? Advisory is a side effect only. Just put an arrow expa, okay? That thing needs to return expa, just as echo of expa returns expa with a side effect.
Okay. Concretely, though, I mean, I'm just trying to understand
what would expa
be. Yeah.
Well, I'm saying you've got a big piece of code, you're evaluating it. And this is saying, well, you're saying, yeah, you're saying, how do I know whether I should generate an advisory thing?
Yeah, there's usually an if somewhere. I mean, it's probably similar to, currently it would be message, right? Now, message also doesn't return anything useful because its argument is not something you need to return. You never look at it again. So I understand that print is sometimes cumbersome to use, but advisory, like message, there's usually nothing sensible to return.
Okay, but let's imagine that internal code, because we need sort of a the internal code is generating messages that are off by default as advisories. Look, I admit that my sub-value thing is not convincing. I don't fully, I agree with you that because of the different generation, the different way that you introduce, I still think there's something to be thought about there about how do you've got a piece of code, you want to insert advisories into the code. How do you do it?
Well, I think, I mean, I pulled up this example earlier because I just wanted to illustrate a different thing. Where'd it go? About where I talked about like why having kind of implicit errors where you don't have to specify a tag are useful, because this is the implementation of the modern package format prototype. I'm not going to worry about that, but it's illustrative code where I'm using a similar mechanism. I have this function, and I just want to write in the thing that went wrong. I don't want to be defining some complex hierarchy of stuff.
Yeah, I agree.
Shift around.
I agree. That's hopeless. Hopeless.
Right.
It's not going to work. Right?
But I think this is a similar structure to what I would do if I had an advise-like mechanism. It'd be the same thing. I've got like, there's some condition I'm checking for if something's not what I expect, and then I'm just going to admit something as a side effect, and then my code is just going to continue. There isn't really a canonical expression that advice might be associated with. It's not really something I want to wrap around something. It's just like,
okay, but
something happened.
Why not? Mm-hmm. I mean, in the case, okay, I admit that this advisory thing, my sub-value advisory thing, is more like a logging function. Right? It's a logging function where you can take action on the outside on something that is being logged, including just log it. Because I think we've been interested in having a logging function. I mean, just write down logging logging with double G. Right. That's a useful thing in its own right. I mean, that's similar to echo. And so the question is can we unify the idea of advisories and the idea of logging? Because we could say, what's that?
Steven, even if you look at the left-hand side here, we use this logging example as motivating example here. And
you're saying login. I'm saying logging.
Logging.
But I'm saying this is
login.
We're using this mechanism to print a log message, but you could imagine a shorter form of this, right? Where
the
logging of tag.
Right, where there's a separate thing. Look, here's what I'm suggesting. Let's say that the overall concept is a logging concept. Okay, advisory, logging, whatever. They're all sort of the same idea. And that your choice of the outer handler is, if you wanted to, you could either, okay, so you've got this logging thing that's being generated. You could absorb, sorry, just a second. Let's see, you could the logging is being produced. Now you can either absorb it somewhere by saying, I want to stop the control flow because I saw that somewhere inside here, I produced a log message that said whatever it is. Or you could simply, as it floats by, you could add something to some log somewhere or some such other thing. You can have a side effect as it floats by, and you can keep it floating upwards.
But I think that this mechanism, most of the time, you are not going to use it directly. Like this is like an hook for other people to use, right? I mean, if I understand this correctly, because you are saying something like, I'm emitting I'm doing the pizza example. I'm emitting the pizza, right? And from the outside, now I can decide whatever, I want to make an invoice, which is a side effect, or I can decorate the pizza, which is a change in the message itself.
Yes.
Those, I think, are the two operations that you want to do. But most of the time, you are going to do it from the outside. And this thing is actually creating like a proper hook inside the code that you can document.
Look, listen. There is the fundamental thing here is there are a variety of hooks that are being produced. And there's either, there are these messages off by default that where they will do nothing unless there is a handler that, pulls them out of the ocean, so to speak, and says, I want to do something with this. Otherwise, they'll just float by. That's case one. And case two is the case which is a genuine exception where you are ejecting from the control flow of the code. Am I right here?
Yes, but there is also an intermediate case. Imagine that somewhere in the middle of the code, some handler that receives this message, so to speak, decides that something went terribly wrong, and then they decide to issue exception from that point in the middle. That's
fine, but there's nothing. That's just a non-absorbing handler. Oh, I see. Hold on.
No, but I think this is fine, Leonid, because let's say that you have a piece of code outside that is doing some sanity check over what you have produced, and I think this is a fine operation to do. Let's say that either like the pizza was too expensive or whatever, like you want to have some business logic that is. That is aborting like the operation.
Right, but the whole point is the non-absorbing function runs its side effect code. That side effect code could be an eject.
Yes, and the reason why I mentioned that is that I think the best logic here is kind of binary. Like in normal circumstances, we never allow these listeners to modify in any way the control flow that would otherwise occur, with the only one exception that those listeners might invoke eject, and that's the only way to change things.
Exactly. That's right.
Yes.
That's right. Or throw or anything else, or any other non-local, control deviating function.
Yes, but my main point has been that the otherwise messages or advices, they are completely invisible for the main control flow or the main expression evaluation.
Yes. Okay, so let's just roll back for a second here. Okay, so we've got four functions here that we know we have. Okay, and they don't have the right names yet. Okay, they are the absorbing and non-absorbing handlers, and they are the eject and advise internal thing. And I really do think we should try and combine the advise thing with this logging thing, although perhaps they need slightly different syntax. Okay, so to me this seems, the names aren't right, but to me this seems to make sense. Do other people agree with that? And then the big other thing we need to discuss is the management of tags.
Yeah. I do think, I think logging, I think we should consider it as a use case for the advice system, right? Like we should spell out, it's such an obvious use case. We should flesh out what we think that would look like and see if we can come up, if we can come up with a good design that works for logging. That's a sign that the more general advice framework
is but I think logging may be its own separate function that has a sub-value character like echo, just because that will be convenient.
Oh yeah. That's what I'm saying though.
So let's just talk about, in the logging case, let's talk about what, I think the typical thing you're going to want to do is a with logging function on the outside that is similar to timing.
Yeah. So this is what I'm imagining, right? So we have, like you said, a with logging like function that just for that scope registers a listener, and this would probably log event.
Registering any listeners. It's just like with logging just basically would pick up any logging. Okay, this is the tag management issue, right? With logging has to either pick up every logging thing from inside it, or it has to pick up a tagged subset of the things from inside it.
Right. And that could be an optional argument to.
Yes, right. But now we have the problem of tag management. Okay, so let's okay. I think we've got a concept here, but the with logging thing, the basic point is no. Just to be clear, that's not the right result. That's not the right result. Well, the right result.
Okay, I'm just trying to write.
Yeah. Okay. Yeah, the right result is something like what we have with timing, which is a list of the actual answer together with the timing data. See what I'm saying? Right?
So, I mean, I guess that makes sense. The only thing that I find weird about that is that logging is something I think of as something that happens like continuously. It's not really a returned result. I more think like, I mean, that you can have functions like gather logs or something.
Okay, whatever. It's a functional language. So okay.
Let me, I just want to make that point though, because like logging is often useful because if something goes wrong partway through, you look at what the last log message is.
I see.
So it's useful because you can't necessarily
you're saying
rely
it's
on
a genuine side effect that's going to somewhere else, like you're logging to a local object or something. Whereas what I'm saying here is, but I think this case is also useful because I think what you're doing here is you've got a bunch of logging messages. Most of the time, the code is working fine. Sometime something goes wrong. And you say, okay, it's like a mechanism for switching on. Okay, here's what it is. It's like you could spray echoes in your code, right? But what I do pretty often is I've got a piece of code, it works fine, something goes wrong, I have to spray some echoes into it. Wouldn't it be nice if I could just leave the things that say logging of blah, blah, blah in my piece of code, but they do nothing unless I have an outer collect the logs type thing.
Right. So I think that they give us three things on the outside. There's absorbing, they do something and it, handles something on the inside. There's non-absorbing, and then there's collecting or invent.
And still, what you describe is exactly the reap-so mechanism.
Yes, it is. Yes, it is. There's a special case of reap-so, in a sense, for these logging things.
Yes.
Okay, but okay. So all right, so let's go back to tag management. Okay. Okay, because the next big thing is, okay, so one base case of the tag management is you've got tags that are burnt into the internal code because they are basically messages off by default. And I really think we need a bridge from the messages mechanism to this. So assume that there are messages off by default that can act as part of the collection of possible things that are generating advisories. Okay. Now you say, well, what other things? We want to basically have these giant buckets. Okay, what Connor has said is when you first write code, okay, there are really two cases because the eject thing is a little different. First when you write the code, you just want to eject. You don't want to say why you're ejecting. You just want to eject for some reason. And then later on, I hate this. This is the thing that we managed to do nicely with enclose confirm is this lexical scoping, which means that you can use enclose confirm without ever thinking about tags most of the time. But this is probably going to be non-local enough. You can't lose that lexical mechanism, right, guys?
Yes.
Yeah.
Right. So, I think just as a general point about non-local stuff, I think part of the idea here is just that the problem with adding tags is that there's like a fair amount of work you have to do on both the throwing and the receiving end. The idea here might be that if you have a more canonical set of tags, that are symbols and that are in this hierarchy and that you register, you can do more. You can just sort of do a lot of that stuff one time when you register the tag.
Well, what about a more extreme version of this? What about if we simply define 15 kinds of tags? Okay. Imagine that we can make an ontology, a taxonomy of errors, and we define 15 of these things. And the user, it's like entities. We've defined a few hundred entity types of, glaciers and planets and who knows what else. You can make your own entity store and add more of them. Actually, it's a bad analogy.
Well, yeah, but I mean, one of the main advantages of the, what we were just talking about for tags as symbols is that you can have them scoped to a particular package.
Right. I mean, I think there is room for having some top level categories that would be, anybody can opt into, but, people.
Right. So you don't have to declare those things because I mean, what I'm worried about is it's a serious level of software engineering to start declaring error types and so on.
But it's true that having like an ontology of errors would allow us internally to maintain some level of consistency between, you know, all the functions that we are developing.
Yes.
Yeah. Well, let me just say, I mean, some of these are probably controversial, but what I've got on the screen here is I was just thinking of, you know, things that might be useful, right? I mean, this is something where, like, you know, okay, like the code got to a point that the programmer hasn't implemented yet. You probably don't want that in finished production code, but that happens all the time when you're fleshing out a project.
Yeah, I like this idea. This is, I mean, this is called, it's like a CRM for code, in the sense that, you know, in a CRM, one of the big points is that somebody has predefined, you know, the stages of a sales process or something like this.
Yeah.
And that's kind of using expert knowledge to predefine. I like this idea, so that people would routinely learn, oh, that's what I put in my code when I haven't finished that part. Yeah.
And also, that's exactly how it works in other languages which have been using exceptions for a long time. They have set of predefined exceptions.
Yeah, you can make your own, but there are others you'll often use.
Like what? But this is a very different idea, because those exceptions are genuine, you know, I don't know, bus error or something, or whatever the heck it is. But you see what I'm saying? That they're a small number of actual, are they not? I mean, divide by zero, things like this. They're very specific. They're like our messages, aren't they?
No, some of them are pretty generic, like IO error, or like, you know, some out of bound error or something.
But what I like about what Connor is proposing here, this is a sort of a programmer management approach, as opposed to, like, I mean, what you're describing are the runtime, you know, the since the beginning of computers type runtime type issues. Whereas what Connor is doing is saying, as code is incrementally being built, these are things that can be there. So in other words, what is saying is there's almost an error that you put in that represents an error of undefined name, you know, in other words, that's one of the things where you go back and maybe we have some coloring mechanism where you can immediately see these are the places where you haven't filled something in, you know, unfilled error type or something. Right?
Yeah.
Sure.
I mean, one thing is you could conceptualize these as like, there's statements about what the programmer thought was, you know, possible to occur. And there's different types of errors, like, you know, an error that represents invalid data from the user, right? Where the programmer could maybe anticipate the user might give them something invalid, but they can't possibly anticipate all the different ways it can be invalid.
Yeah.
And so it's much more dependent on...
No, I like this idea. This is a good idea. I mean, but this is an ontology of programmer errors, basically, or programmer as opposed to an ontology of things that go wrong in the innards of our system, like divide by zero and so on.
Well, he also has those right above, right? He has file error, and not sure what the difference is between IO error and file error.
File error, I'm imagining it would have like, it would be, its validator would ensure that it has a path to the file where something went wrong.
I need to disappear in a second here. This is but those standard error types are way anemic relative to what they should be. If you go through and look at the error documentation, there are I think that will be a good exercise for people to do, is go through and look at that and try and see whether you can come up with reasonable buckets for that. I think those aren't really close to the right buckets. They're things like, well, I don't know. I mean, they're things, and some particular messages might be in two categories. See what I'm saying?
Yeah. Well, and that's why, I mean, the tag mechanism lets us do that, right? If there's a location in the code where an error is issued that is, you know, a file-like error and a something else-like error, it would be tagged as both.
Yeah, I understand. And the handler should just use pattern matching syntax, at least, of A vertical bar B type thing to catch multiple things.
Yeah.
My view. All right. I should run. This is very useful. This is really good progress, I think. And And I feel actually, I think the next step is for you guys to look. I mean, there's obviously a bunch of naming things that are just total disasters here, and that would be, but I think a very good next step will be to actually look at the current messages that we have and try and make them into bucketed errors. And I really like your idea of defining these, an ontology of sort of programmer issues, so to speak.
Yeah. Well, do you want? I mean, so our general thinking, at least my general thinking, I can't speak for everyone, was that we'd be well served to try to think like in the modern world, what do we think the useful categories are? Maybe taking inspiration from messages that already exist, but not necessarily purely trying to sort messages that already exist. Figuring out what we think the useful buckets are, and then going back and, trying to slot messages into those buckets rather than trying to like start by grouping existing messages.
I think it's inspirational to look at the existing messages.
Yeah, that I agree with. We should look at them to get a sense of
I'm not claiming
scope.
that it has to be.
Okay. You're not suggesting we just flesh out message groups, essentially. You want, yeah. I mean, that would be like the really low level thing to do, which I think is not quite right, to just come up with more message groups.
Oh, the message groups right now are really lame.
I think Python is one of the few languages that got a very nice set of built-in exceptions. So that is something we should take a look at as well.
Okay. Well, but look, we didn't know. Okay, the only thing that we thought we were doing with the current message groups was the off mechanism, off and on mechanisms and so on. Okay. It was a different purpose that those groups were developed for. Now we have a much more programming-oriented reason to do them. Plus, as I keep on emphasizing, messages that are off by default are really important, and we should put a lot more in. And if that mechanism is, maybe we need to, because really the only difference between the mechanism you're proposing and existing messages is the mechanism you're proposing has an association rather than positional arguments.
Yeah, I think that's,
Right. Okay. Let's get another one of these meetings soon and continue, but we can't do that right this second.
Yeah.
Okay.
I think what we should plan to do is we could collect some data on, Ricardo mentioned how Python does things. We'll get our own list of messages, do some initial sorting work. But I think it might be helpful to just have a meeting that's about, let's try to figure out a hierarchy for these. We can do some preliminary work, but I don't think
that would be great. Yeah, but I think, and if you can clean up the things we've discussed in terms of design and try and come up with possibly some naming for all of these, kinds of objects. And I do think that because logging is going to be one of these functions, I think, it doesn't want to all be all about failure. I just think it doesn't necessarily want to have that level of sort of, judgment or something, maybe. I'm not sure. I really have to go. I'm sorry. This was not scheduled for so long. I would like to continue this, but I really can't right now.
Okay. Well, thanks for the time.
Yep. Well, thank you. Good work. This is great. This is progressing.